I'm just gonna read some PLC basics, and I'm gonna read the history of automation, what is automation, and stuff like that. So right now, let's go to the history of automation. Learn what is it all about. Takes some time to process, but it pisses me off when it does stuff like this, because I don't like slow things actually. History of automation. Automation can be defined as the technology by which a process or procedure is performed without human assistance. Automation has been achieved by various means, including mechanical, hydraulic, pneumatic, electrical, electronic devices, and computers, usually in combination. Complicated systems such as modern factories, airplanes, and ships typically use all these combined techniques. The benefit of automation include labor savings, savings in electricity costs, savings in material costs, and improvements to quality, accuracy, and precision. The term automation, inspired by the earlier word automatic, coming from automaton, was not widely used before 1947, when Ford established an automation department. It was during this time that industry was rapidly adopting feedback controllers, which were introduced in the 1930s. Number one was manual control system. Number two, pneumatic control system. Number three, hardwire controlled system. Number four, electronic control using logic gates. Number five, programmable logic controller. Manual control. All the actions related to process control are taken by the operators. Drawbacks, likely human errors, and consequently its effect on quality of final product. The production, safety, energy consumption, and usage of raw material are all subjected to the correctness and accuracy of human action. Pneumatic control system. Industrial automation, with its machine and process control, had its origin in the 1920s with advent of pneumatic controllers. Action were controlled by a simple manipulation of pneumatic valves, which in turn were controlled by switches. Drawbacks. Bulky and complex system. Involves a lot of rework to implement control logic, longer project time. Programmable logic controller. In 1970, with the coming of microprocessor and associated peripheral chips, the whole process of control and automation changed. Instead of achieving the desired control automation through physical wiring of control devices in PLC, it is achieved through a software program. It can be effectively used in the application ranging from the simple control like replacing relays to complex automation problems. Now, programmable controllers used as the universal element in industrial automation. That was a brief history of automation. Now, let's go to what is automation. Automation. Automation is a delegation transfer of human control process to technical equipment to increase accuracy, quality, ultimately productivity, and to reduce cost. Automation increases safety at working place. Automation enhances faster processing with some consistency and accuracy. It is economical for larger systems and complex functions. It facilitates easy database storage, long-distance data transmission, easy analysis over any problem. Automation systems may have microcontroller, microprocessors, PLC, DCS, PID, etc. PLC replaces hardware relays, timer, counter with software components. That is explanation of automation. Now let's go to another. Information on gates. Information on gates. Gates. Introduction. Logic gates process signals which represent true or false. Normally, the positive supply voltage plus or 5 voltage represent true and 0 voltage represent false. Other terms which are used for the true and false states are shown in the table. It is best to be familiar with them all. Gates are identified by their function. AND, OR, NOT, NAND, NOR, EXOR, and EXNOR. Capital letters are normally used to make it clear that the term refers to a logic gate. The above said logic gates can be classified into following categories. Number 1, basic logic gates, AND gate, OR gate, and NOT gate. Universal gates, NAND gate, NOR gate. Number 3, combinational gates, XOR gate, XNOR gate. We'll learn more about them later on. Now let's go to PLCs. PLCs. What actually is a PLC? And how will it help us in automation and stuff like that? Let's read more about it. Introduction of PLC, programmable logic controller. NEMA defines a programmable logic controller as a digitally operating electronic apparatus which uses a programmable memory for the internal storage of instructions by implementing specific functions such as logic sequencing, timing, counting, and arithmetic to control through digital or analog input or output modules, various types of machines or processes. A programmable logic controller is solid-state computerized industrial controller that performs discrete or sequential logic in a factory environment. Programmable logic controller, which usually called a PLC or more commonly simply a programmable controller, is a solid-state digital industrial computer. Programmable logic controller or PLCs, also referred to as programmable controllers, are in the computer family. They are used in commercial and industrial applications. A PLC monitors inputs, makes decisions based on its program, and controls outputs to automate a process or machine. This course is meant to supply you with basic information on the functions and configurations of PLCs, traditional PLCs or PLC application. Point number 1 is that in automated system, PLC controller is usually the central part of a process control system. Number 2, to run more complex processes, it is possible to connect more PLC controllers to a central computer, which is now called integration. History and chronological evolution, I think, of PLC. That's how they wanted to say it, I think. Let's see. History and chronological evolution of PLC. History of PLC. PLC development began in 1968 in response to a request from an US car manufacturer, GM. The first PLCs were installed in industry in 1969. Communications abilities began to appear in approximately 1973. They could also be used in the 1970s to send and receive varying voltages to allow them to enter the analog world. The 80s saw an attempt to standardize communications with manufacturing automation protocol, MEP, reduced the size of the PLC and making them software programmable through symbolic programming on personal computers instead of dedicated programming terminals or handheld programmers. The 90s have seen a gradual reduction in the introduction of new protocols and the modernization of the physical layers of some of the more popular protocols that survived the 1980s. The last standard, IEC 1131-3, has tried to merge PLC programming languages under one international standard. We now have PLCs that are programmable in function block diagrams, instruction lists, C, and structured text all at the same time. Chronological evolution of PLC. 1959. First solid-state control system designed by AB to replace the relays, but it was not programmable. 1969. PLC manufacturers by Moricon for General Motors Corporation. 1972. Moricon introduced fully programmable PLCs using ladder logic and solid-state I/O with their microcomputer processor. 1979. AB introduced PLC 2 out of 20 provided with advanced control facilities with intensive fault diagnostic, analog modules, signal interface position controls. 1981. Data highway enabled users to interconnect many PLCs at distance of up to 4,500 meters. More 16-bit PLCs become available. 1990. Standardization process for many PLC for many field buses started. I think I have to stop it here.